Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Muhammad Iman Haziq bin Muhammad Iskandar, and today our group will be sharing with you guys about the subtopic of chapter 7, which is Eigenvalues and Eigenvectors. Firstly, I'll be telling you guys the definition of Eigenvalues and Eigenvectors. Given that an unknown matrix, which is put in n by n matrix, with a scalar lambda, which is called an eigenvalue of A, with a non-zero vector x. Just from these three variables, which is A, lambda, and x, it can actually form a simple equation, a simple formula, which is Ax equals to lambda x. So from this equation, so here A is a given matrix, which is an n times n matrix, and here the value of x is the eigenvector, same as this, the x is eigenvector, and for the lambda will be the eigenvalue.
Okay, this is the example 7.17. Show that x12 is n eigenvectors of A 3, 0, 8, -1. Hence, find the corresponding eigenvalue. Okay, here's the solution. First step is we times the A and x, and we got this 3, 6. And we factor this value to get the eigenvectors, the x, to show the eigenvectors. Okay, since ax equals to lambda x, the scalar lambda is called an eigenvalue of a corresponding to the eigenvectors. This, this is the eigenvalue. Therefore, the corresponding eigenvalue is 3.
For the next definition, we have the definition for eigenvalues. Based from this whole statement, we can say that the eigenvalues can be found from this equation, which is a matrix of lambda multiplied by identity minus with n by n matrix of A, which is equal to 0. We have some examples which will be presented by my friend.
Example 7.18. Determine the eigenvalues of eigenvectors for the matrix A. Okay. Step 1. Write down the characteristic equation. This is the equation for the characteristic equation. This is the answer. We can use calculator to find all of this. This is sum of diagonals. This is sum of cofactor diagonals. And this is the determinant of matrix A. First of all, we try to find determinant of A. First step is we go to mode, select number 6 matrix, and we choose matrix A, and our matrix is 3 times 3 matrix, 3 by 3 matrix. So we choose 1 and we put the value 1, 1, 2, 0, 2, 2, -1, 1, 3. After that, we select AC and we go to the shift and we choose this number 4 matrix and we go to the determinant and we select shift back, we go to the matrix, we we put the number 3 matrix A that we have put the value, and we will get the determinant of matrix A, 6. We got this. Next, we're trying to find the sum of covector diagonals equals to determinant of A times with A inverse. So we get the value of determinant 6, 6, and with times with, we go to shift matrix times with matrix A inverse, and we will get this matrix. So we take the sum of covector diagonals here. So it will be sum of 4, 5, and 2, and we will get 4 plus 5 plus 2 equals to 11, and we will get this value. Last, we find the sum of diagonals of matrix A, which is this. 1, 1, 2, and 3. So the total is 6. We got this value. Next, step 2, find the roots or eigenvalue. By using trial and error, we can take lambda equals to 1, and it will give P1 equals to 1 cubed minus 6, 1 square, plus 11 times with 1 minus 6 equal to 0. Thus, lambda minus 1 is a vector for P lambda. By using long division, we will get the value of lambda. Therefore, P lambda equals to lambda minus 1 times with lambda minus 2 times lambda minus 3 equals to 0. Hence, the eigenvalues of matrix A are lambda 1, 2, and 3.
Hi, my name is Iman, and now I'll continue with the step 3. We know that the value of lambda is equals to 1, 2, and 3, just from the one that my friend did before. So just from the value of lambda, we can actually find the value of eigenvector, just from this given formula that we know, which is Ax equals to lambda x. From this formula, it can also be told as in Ax equals to lambda times by identity times by x, as identity, when it is the product of this, will actually be the same as the previous one that we know here. We know that the value of matrix A is 1, 1, 2, 0, 2, 2, negative 1, 1, 3, and the value of lambda is equals to 1. From there, we can slot in the value into this equation, and when it is rearranged, it will give us into this form. So we have this matrix, which is the lambda times by identity. So when the lambda is equals to 1, it will give us this matrix, and the product of the subtraction of these both matrix will give us this matrix, which is 0, negative 1, negative 2, 0, negative 1, negative 2, 1, negative 1, negative 2. From here, we can proceed with the ERO just for this matrix, or the RREF, which is reduced row equivalent form, and from there it will gives us 1, 0, 0, 0, 1, 2, and 0, 0, 0. From here, we can actually find two different equations, which is x1 is equals to 0 and x2 plus 2x3 is equals to 0, which I have written down here, which is x1 equals to 0 and x2 plus 2x3 is equals to 0. Therefore, we can summarize it as x1, the value of x1 is equals to 0. Meanwhile, after we arrange this equation, will gives us that the value of x2 is equals to negative 2, while for the value of x3 is equals to 1. Next, we have when the value of lambda is equals to 2. We know that from this formula, we can actually find the eigenvector, and from there, we can, same as before, we know that the value of lambda is equals to 2. When it is being multiplied by the identity, it will give us this matrix, which is 2, 0, 0, 0 to 0, and 0, 0, 2. And the product of this subtraction will give us this matrix, which is 1, negative 1, negative 2, 0, 0, negative 2, 1, negative 1, negative 1. Sorry, reminder, this is the value of A, is from this formula. So we know that here is the subtraction, the product of the subtraction of these both matrix. From there, we can proceed, same as before, after we get the product of the subtraction, we can proceed with the ERO, or the reduced row equivalent form, and it will give us this value, this matrix, which is 1, negative 1, 0, 0, 0, 1, and 0, 0, 0. From there, we can it will give us two different equations, which is x1 minus x2 is equals to 0, and x3 is equals to 0. And I've written down here. And when the first equation is being rearranged, it will give us x1 is equals to x2, which and for the x3 is equals to 0. From there, we can sum it up as the value of eigenvector for x1 will be equals to 1, and for the value of x2 is equals to 1, and for the x3 is equals to 0, which has been written, we can see here in the note. For the last one, we have when the value of lambda is equals to 3. And based on the equation that we know, which is the lambda times by identity minus with the matrix A, which these both is inside bracket, being multiplied by the eigenvector is equal to 0. From there, the product of the subtraction of these both matrix will give us this matrix, which is 2, negative 1, negative 2, 0, 1, negative 2, 1, negative 1, 0. Then we can, after we get the this matrix, we can continue with the ERO, which will have the new matrix, which is 1, 0, negative 2, 0, 1, negative 2, and 0, 0, 0. From there, it tells us that it has two different equations, which is x1 minus 2x3 equals to 0, and x2 minus 2x3 is equals to 0. And you guys can see that equation here, which is x1 minus 2x3 is equals to 0, and x2 minus 2x3 is equals to 0. From there, after we arrange them, it will give us x1 is equals to 2x3, and for x2 is equals to 2x3. Therefore, we can summarize it up as the value of x1 is equals to 2, and for the value of x2 is equals to 2, meanwhile for the value of x3 is equals to 1. Since we have known all the value of eigenvector based from all the lambda that we know, which is 1 to 3, we can recheck it back into this known formula that we know, which is Ax equals to lambda x, which we can put A, the known matrix, and the value of x, which is the eigenvector, and from there we can multiply both of this, and if the value is the same as the product of this, it means that the eigenvector is correct.
Okay, now we move on to the next example. And this example, we will use the 2 times 2 matrices. The question is, determine the eigenvalue and eigenvector for the matrix B, which the entrance 1, 2, 3, 2. Okay, the first step is we need to arrange it to the characteristic equations, and we get this. This is the first step. And the second step is we need to find the determinant for the 2 times 2 matrices. We have to divide the leftmost, the top leftmost, divide by the bottom rightmost, and minus the 3 times 2. Then we will get this equation. It's a quadratic, so we need to solve it. So once you find the value of the lambda, then we will find the eigenvalues. So in quadratic equation, we will find there is 2 factor. So when you get the 2 different eigenvalue, you will also find the 2 corresponding eigenvector as well. So we move on to the third step, where we substitute the lambda value into these matrices. We have to solve this by using this equation. Matrices C is the matrices B that have been divided by lambda times the identity. So we will multiply it with the unknown matrix and equate it with the null matrices. So when you multiply these two values, you will find the 2x1 plus 2x2 equals to 0. Or you can cancel it out and find out that x2 equals to negative x1. So if x1 is equal to k, where k is a constant, so x2 equals to negative k, then the matrices, x matrices have the entrance k, negative k. So we can write it as, this is the constant k with the entrance 1, negative 1, and the corresponding eigenvector is 1, negative 1. So we will move on to the next eigenvalue, which is 4. Oh wait, okay, now we can see it. Also, you have to solve it with these equations. Matrices C times matrices X give the equals to null matrices. So the lambda here is 4, then you have to minus it, then you get the entrance, and the matrices C is negative 3, 2, 3, negative 2 times, we need to solve it and we need to times with the x1, x2. Then we will have negative 3x1 plus 2x2 equals to 0. So we rearrange it and arrange x2 in terms of x1. We will get x2 equals to 3 over 2 x1. So if x1 equals to 2k, where k is a constant, so x2 equals to 3k. You get it? And the matrices X equals to 2k 3k, and we can factorize it equals to k to 3, and we find the corresponding eigenvector is 2 3. Okay, that's all for the determine the eigenvalues and eigenvector for the 2 times 2 matrices.